I mean, honestly, it sounds like they're speaking a foreign language. In my research methods class, they use words like nominal, ordinal, interval, and ratio. What do these even mean? Well, all of these are levels of measurement. And if you have 7 minutes, we can teach you the difference. Hey, it's Dr. Pamela Kreiser here at the Research Methods Crash Lab. We're here not only to help you survive your methods class, but we're here to help you thrive. Now, if you hate math, you've come to the right place, because here at the Crash Lab, we're ready to help everybody. Let's head into the lab. Now, every class talks about data levels, but what the heck is the difference? How are you going to know this for an exam? Well, the answer is simple. We capture data in a number of ways. One of the most basic principles is the levels of measurement used in data analysis. So let's examine 4 measurement levels: nominal, ordinal, interval, and ratio. The first distinction that you notice in this diagram is to differentiate categorical data from continuous data. By this, we mean that the data are collected in categories versus a continuous format. Next, we look at these areas and see the specific measurement related to it. So let's start by looking at the categorical data collection, and then we'll go on to the continuous data collection in a minute. So let's look at nominal and ordinal measurement. For nominal measurement, it means that we capture the data in name only. You might think of this as named categories. For example, individuals might identify a personality tendency, such as a preference for expression. The choices might be extroversion versus introversion. Now, when individuals respond with their answers indicating whether they identify with extroversion more than introversion, that represents a categorical response. In this case, you're indicating that preference, and we've now captured that in a named category. Another example of nominal measurement would be to ask individuals to identify their undergraduate major. An individual could review a list of majors and check off their specific degree. In both of these examples, the questions provide categorical information about the participant, in this case, nominal data. Now, as you might guess, nominal level data has limitations because it only identifies general information. And because of this, it is also mathematically limited in terms of analyses. Our next level of measurement is ordinal. For ordinal measurement, it means that we capture the data in categories, but these categories are also ordered. In other words, order matters. Now, our example of ordinal measurement could be level of education. On a survey, the categorical choices might be high school, college, or graduate level of education. Here we see the categories, but we also see that they're in ascending order, meaning the order reflects more or less of something. In this case, education. Another example of ordinal measurement might be the indication of skill level. For example, a person who is playing tennis might say beginner, intermediate, or advanced. Now, in both of these examples, they're ordinal in that they have categorical information, but a logical ordering. Both nominal and ordinal measurement levels are considered categorical. This means that the measurement captures categories and the assigned numbers. We note also for this level of measurement that there can be limited variance because there's only so many categories that are captured. Now, as a researcher, when you're constructing categorical measurement, there are 2 governing rules. One is that the items must be mutually exclusive, and 2, the items must be exhaustive. Now, by mutually exclusive, we mean that the construction of the categories must be distinct and not overlap. For example, an individual responding to a survey should only have one answer to mark. Multiple answers should not apply to the individual. But if there are multiple answers, the researcher can simply revise the item so that there isn't this problem. Now, second, we note the measurement must be exhaustive. By this, we mean there is enough categories available to capture all of the data. In other words, an individual responding to a survey should have a place to put their answer. Having no place to answer also indicates a violation of this standard, and this also needs revision. Now, let's explore continuous data measurement levels. We consider continuous data to be superior to categorical data because it captures more variance and has more options for analysis. The first type of continuous data is interval. Interval level data is classified as being in logical order with the presence of equal intervals, but not an absolute zero. For example, an institution might be interested in determining academic training. Researchers might decide the SAT test is an indicator of this training. Now, individual SAT scores are considered interval because they are scores with equal intervals, but no absolute zero. Specifically, the scores are equal in their distances. This is because mathematical numbers are equally distant from each other. But we also note that the SAT score also has no absolute zero. The lowest score available on a SAT test, for example, is 400. So even if an individual missed every item on the SAT test, the lowest score would be 400 for that person. Another example is the Amazon star rating system. This is used by individuals to rate products, and the scores from these multiple raters are added together to create average rankings. Now note, this system has equal intervals. The distance of a 3-star rating to a 4-star rating is the same distance as a 4-star rating is to a 5-star rating. They have equal intervals. But note, this measurement does not have an absolute zero. The lowest rating on Amazon is a 1-star rating. Our last level of measurement is ratio measurement. Ratio level data are classified as being in logical order with the presence of equal intervals, but also with an absolute zero. Let's suppose an agency was interested in determining financial need for assistance. The researchers might decide that income is an indicator of this financial need. Income is considered ratio because it involves numbers that are equally distant from each other, as well as the presence of an absolute zero. Zero income is an available choice. A final example of ratio measurement might be determining work experience. The researchers might decide that years of service is an indicator of work experience. Years of service is considered ratio because it involves numbers that are equally distant from each other, as well as the presence of an absolute zero. 0 years of service is a possible choice. Now, in our review of the 4 levels of measurement, we've talked about nominal, ordinal, interval, and ratio data. A way to remember this is to think about the wine Pinot Noir. Using that acronym, we can remind ourselves that it's nominal, which is categorical measurement in name only where order doesn't matter. Ordinal, categorical measurement where order does matter. Interval, which is continuous measurement with equal intervals, but no absolute zero. And ratio, continuous measurement with equal intervals and an absolute zero. In the end, we know that all of the collection of levels of data yield different information, different levels of variance, and the ability of the researcher to explore more or less options of analysis based on these data. So now you know the difference between nominal, ordinal, interval, and ratio level data. Now, earlier in this video, we promised to give you a strategy to help you improve your test scores. So you ready to take the next step? You can access our Quiz Me videos using the link here and test your knowledge. Well, thanks for watching, and if you like what you saw, make sure you hit that like button down below, and we'll see you in the next one.